Hello grade 8s, this is Mr. Miller and welcome to lesson 10.4, which is all about modeling and solving two-step equations part 3. So we've seen two other types of two-step equations. This is the third type, and just a quick note as you're taking a look at your lesson notes here and wondering how the heck am I going to fit into number 1, a model and then solving and also doing checking all in one. Well, I agree, it's a little bit too much to fit all into the first examples. So we're going to leave the check off, although we'll certainly talk about how we can verify verbally. So let's take a look at that first example where we're going to be just doing the modeling of each equation with algebra tiles and then solving. We will talk about how to do a check, but we won't write that out formally. So there's not a lot of room to do that here. Taking a look at that first equation, you'll notice that what's different here from in between this equation and the ones we've seen in the previous two sections is that we've got some brackets. So we've got an operation in brackets, a subtraction, and then we've got 4 times all of that. So when you go to model that with the algebra tiles, it looks like this. We have 4 groups of the entire d minus 3. So here's the d minus 3, and you notice that we have 1, 2, 3, 4 groups of those. On the other side of the equals, we have negative 8. And so there's what our model looks like in the first place. Now, you may have noticed that the first set of tiles on the left, we've got 4D tiles. Then we have negative 12, and then of course we have the equals and we have negative 8 on the other side of the equation. So this process of rewriting the left-hand side of the equation in this way, basically multiplying the 4 times d to give you 4d, and multiplying the 4 times negative 3 to give you negative 12. Some people call this expanding the brackets because it's effectively removing the brackets from the equation. But more formally, this process is called using the distributive property. Okay, so I'm just giving you that terminology right off the bat just so that you're familiar with that. And there will be some questions in your textbook and possibly on a test that will ask you to use the distributive properties. So this is what you do. You expand the brackets. Now what we can do from here is now this equation looks a lot like equations that we've solved before. So what we've got is 4 times d and then subtracting 12. So what we can do here is we can add 12 to both sides, right? Which leaves us with just 4d equals 4. And then we can divide into 4 equal groups, okay, dividing both sides of the equation by 4, and this leaves us with d equals 1. And that's the solution of the equation. Now, like I said, at this point, there's not really a lot of room for us to do a check here, so let's just talk about how we know this is a valid solution for this equation. If I were to take this d equals 1 and put it in here, 1 take away 3 would give you negative 2 inside the brackets, and if you multiply 4 by negative 2, that does give you negative 8. So as you can see, this d equals 1 is the value that makes the left-hand side equal to the right-hand side. So it is a good solution for this equation. Let's move on to number 2, and we've got a similar but different equation. We've got the variable on the other side of the equals. That's not really such a big deal. We do have brackets as we had on the previous one, but one key difference is that we've got negative 3 times all this in brackets. And that certainly makes things a little bit more challenging to represent in the model. So let's take a look at how we can represent it. So what I did here, instead of having k take away 4, I had the opposite of k minus 4. So it's negative k plus 4. So in negative 3, dealing with the negative part, is just telling you that you've got the opposite of k minus 4, and not only that, but you have 3 times the opposite of k minus 4. So that would be negative k plus 4, and we've got 3 groups of those. On the other side of the equals, we do have the negative 6, and now we've got our equation represented in this model. What we can do from here, and I'm going to use a different method than I used last time. I'm not going to use the distributive property. I don't actually find that it's the most efficient way of doing things, because you'd have to use the distributive property, then you'd have to use the method of inverses, which involves 2 more steps. So here what we're going to do is we're going to go straight to the method of inverses, and really it can be done in 2 steps. There is an extra one that we need to put in here because we're using a model, but normally it's just 2 steps. So let's take a look. I mean, basically what we're doing here is we are subtracting 4 from k, multiplying by negative 3. So we're going to divide by negative 3 and then add 4. That's what we're going to do to solve. Now the divide by negative 3 part is something that we're going to have to do in 2 steps because we're using a model. So let me just show you what that looks like. Split it into 3 equal groups first of all. That's dividing by 3, and this is what we get. We end up with negative 2 on the left, and we have the opposite of k minus 4, which is negative k plus 4. So that's dividing by 3, and now we'll deal with the fact that there's a negative, and we'll flip everything over. Okay? So you notice that the negative 2 became positive 2, the negative k became positive k, and the positive 4 became negative 4. So what it's equivalent to in terms of the algebraic work is dividing both sides of the equation by negative 1. So that leaves you with 2 equals k minus 4. Now, if I wasn't having to show this model and the progression of the model here on the right, I would normally do these 2 steps actually in one. I would normally just divide both sides of the equation by negative 3, and that leaves me directly with k minus 4 equals 2. So in any case, our last step here is going to be to add 4 to both sides of the equation, both in the model and algebraically I'm going to show that, and what we end up with is k equals 6, which is the solution of the equation. And now again, there's not really a whole heck of a lot of room left over here at the bottom to do any kind of a check, but let's talk it through. If we have k equals 6, we plug it in here, we replace the k with 6. 6 take away 4 is 2, and times negative 3 is negative 6. So this is the k value that makes the right-hand side equal to the left-hand side. In other words, we have satisfied this equation and made it true. So now let's move on to number 2, where we're going to solve and verify, or solve and check. And since it said solve and it didn't require for us to use a diagram, I'm not going to do a diagram for this one. I'm just going to go straight to using the method of inverses. So I ask myself this question: what is being done to y here? Well, we're adding 4 and multiplying by 7. And so what I'm going to do to solve this is I'm going to divide by 7 and then subtract 4. So notice this is the doing order, and the undoing order goes in reverse. So we start by dividing both sides by 7. This gives you 6 equals y plus 4. And now we can subtract 4 from both sides, and it leaves us with y equals 2. That's the solution of the equation. Now we want to check to see if this is valid. So we start with the original left-hand side, which was just 42, and the original right-hand side, which was 7 times y plus 4. We replace the y with what we think is the correct solution, and then we calculate. And as it turns out, the left-hand side and right-hand side are equal to each other, so we know we have the right solution for this equation. And now moving on to part B, we've got another equation with brackets here, and start by asking yourself, what is it we're doing to C? Well, we're subtracting 10 and then we're multiplying by -4. And you can jot that down somewhere. And so now what we want to do is we want to undo this in reverse. So we're going to divide by -4 and then we're going to add 10. So starting with dividing both sides by -4, we end up with c minus 10 equals -10. And now adding 10 to both sides leaves you with c equals 0. So now to check this, we start with the original left-hand side and right-hand side, replace the variable with what we think is a solution, and calculate. We can see that the left-hand side and right-hand side are equal to each other, so this is the correct solution for this equation. Sorry, a little bit of a delay in those last couple of letters showing up. All right, so moving on now. Number 3, it says to show whether x equals 4 is the solution to each equation. So the difference here between this and what we did in the previous example is that we only have to check x equals 4. We don't have to actually solve these equations. So starting with this one, again, if we want to check x equals 4, we copy down the original left-hand side and right-hand side, replace the variable with what we think is a solution, calculate. We notice the left-hand side and right-hand side are equal to each other, so we know that x equals 4 is the right solution for this particular equation. We've done lots of practice with checking solutions of equations, so at this time I'm not going to show you just yet how to do B, C, and D. Take a second to try this for yourself. After you've done that, and so pause the video and give that a shot. After you've done that, then play the video and see if you've got the right, if you've done your checks right. Okay, go ahead and do that now. Okay, so at this point, you should be ready. You should have done B, C, and D on your own, and you're just making sure that you've done those right. So here is what part B should look like. Checking x equals 4, left-hand side is -15, right-hand side is -3x minus 9, replacing that with 4, calculating. Left-hand side and right-hand side are not equal to each other, so this is not the correct solution for this particular equation. Moving on to part C, if you use x equals -4, left-hand side is 24, the right-hand side is 4 take away 1 is 3 times 8 is 24. Left-hand side and right-hand side are equal to each other, so x equals 4 is the right solution for this equation. And the last one, checking x equals 4, the left-hand side is -5 times x plus 2. Replace the x with 4. Calculate, you get -30. That matches the right-hand side. So that means that x equals 4 is the correct solution for this equation. And now moving on to the last part here, number 4. This is a word problem. So let's read through this together. It says, if you take the number of points the Panthers football team scored in their first game, add the 21 points they scored in their second game, and double the total, you will get 62 points. The question is, how many points did they score in their first game? So some of you may know already what the solution is because you're just that quick. Other people maybe need to think about it a little bit more. Regardless, if you have no idea what to do, you should start off with looking at, well, what is it we're trying to figure out? The number of points they scored in their first game, make that your variable. So let f be equal to the number of points that they scored in their first game. You get a mark for doing that. Next thing, you need to make an equation. So I'll just point this out that we've got f plus 21 first, the number of points that they scored in their first game, and we add 21 points to that, which is the number of points they scored in their second game. That's the first thing. And then you double the total, so 2 times all of that. You will get 62 points. So now the question is, how many points did they score in the first game? Well, we've got to solve the equation now. So whether you expand the brackets or use the method of inverses, that's up to you. Me personally, I'd rather use the method of inverses, so I'm going to divide both sides by 2 first, then subtract 21, and this gives me my solution. And now I can write my full sentence answer, so therefore the Panthers scored 10 points in their first game. So that completes the final lesson of Chapter 10. And if you had any questions about this lesson or any of the other lessons from Chapter 10, please do not hesitate to ask in class, and look forward to seeing you there. Have yourselves a lovely day. Bye-bye.